Welcome to data structure course. Hello student, I am Swapnil Chaudhary. In my previous video, we learned why we learn what is the problems with array, what is the problems with array, then how we can overcome that problems with a linked list, and then we learn some implementation part like how we can implement linked list in a C programming. Also, we learned the definition of linked list. Okay. Again, linked list is a order data structure. So now in this session we are going to see the types of linked list, the types of linked list. Okay, so linked list basically divided in the types of linked list is like singly linked list, singly linked list. Okay, the another type of linked list is what? Doubly linked list. Okay, then next type of you can say headed linked list or header linked list. Okay, and then next type of linked list is a singly circular. Okay, see, okay, I'm going to write here singly circular linked list. Then another type is doubly circular linked list. Okay, so these are what basic types of linked list that we are going to cover in our syllabus. Okay, so first what we are going to do, we are going to start with a singly linked list. Okay, we are going to start with a singly linked list, then we are going to see doubly linked list. Okay, now so start with a singly linked list, singly, okay, linked list, singly linked list. So now we are going to see basic operation which we are going to perform on singly linked list. Like the most basic, it is same like the basic operations we are going to perform on different data structures, like whatever operations we perform in stack, queue, linked list. So basic operation is like create that particular data structure. So basic operation is what? Create. Then the second one is the insertion. Then the next one is a deletion. Then some in insertion you may, again it is divided in a different type, like insert at the beginning, insert at last. Then you can say insert after particular element. Suppose you have some elements in a linked list, so like 10, 20, 30. So there are different operation. Insert after 20, insert after 20 means in between 20 and 30. Okay, insert after 20, so it will join like this. Okay, or insert before 20, so before 20 is like this. So these are what different types of insertion operation. Likewise, insertion you can perform different types of deletion operation. Okay, then you can perform like search operation, basic operation, then sort operation, or the and search sort to find the length of linked list. Then few more basic operation. Reverse this linked list means this is what your linked list, we are going to reverse it like this: 30, then 30 will point to 20, then 20 will point to 10. So this kind of basic operations we are going to perform on a linked list. We are going to see one by one. But the most important part of this implementation or learning part in a C programming or in a data structure, how we are going to declare that node structure. So we already covered that part in our previous session. Okay, how we declare or how we implement this the data structure. Okay, now we are going to see the basic operations, okay, on the linked list data structure. Okay, so most basic is what? Create operation. Okay, so here I'm not going to explain you algorithm for that one. I'm going to explain you C code for that. Okay, C code. So you can implement this code on your terminal, and you can see it practically. Okay, so to create a linked list, suppose I am going to create a linked list, so I am writing one function for that. So create function for which create the linked list, initialize the linked list. So very simple, it is a so what I need to do to create a linked list, what I'm going to do is, this is what your structure. I'm going to first rename that structure. I'm going to first, before this create function, I'm going to rename that structure like using type def keyword, type def. So sorry, so every time I doesn't need to write that struct node. So instead of that, what I'm going to do, I'm going to type def it by another name, that is struct node. Every time I doesn't need to require like write again and again this line of code. I'm going to rename it by node. So I'm use capital node. Okay, capital name. So we are not going to write struct node every time. Instead of that, we are going to write simply node. So after this renaming it, what I'm going to do, I'm going to declare some variables for this structured data type. So write node, node capital, and again it is a pointer type variable L. So this is the link part or start point of node structure. Okay, end with semicolon. So same this node, whatever a node I'm created, I'm going to write here. If I'm just declare this variable, I'm not assigning any value to this variable. This is node type variable. So here I'm going to use that if L is equal to what I'm going to do, I'm going to create. So if so here what I'm going to write, L is equal to null. L is equal to null. Null is a keyword in a C programming which assign the null value to that particular variable. So this is a pointer variable, and that pointer variable, this is a pointer type node type pointer variable, and we are going to assign null to that. L means what? It is a empty. It is a empty. Now we just created the linked list which is a empty. So this is what your L, and now this is a L variable, and now it is holding the value null, nothing. Okay, which is holding the value null. Now what we are going to do, the most important part is what? We just declare the variable, but we are not assign value, we not allocate the memory for this variable. This is a structure variable, no issue about it. This is what? Structure variable. But we are not allocated memory for that one. This is an ordinary pointer variable. And to that pointer variable, we just assign the value is null. But we are not allocate memory for that one. When you are going to assign the value in a data field, this is a data field and a link field. For that purpose, you need to assign or allocate memory for that particular thing, that particular variable. Okay, see, in structure, that is user defined data type, if suppose you declare the structure variable, that doesn't make sense that you are allocate memory for that one. So what we learn, in a linked list we allocate memory in dynamic form, means at the execution time, at the runtime. So for that purpose I need to write the function, okay, which returns the node type value, node type pointer value. So what I'm going to do here, I'm going to write the functions which allocate memory for this node, in a memory, computer memory. Okay, so get node is the function which allocate memory for this variable. Get node, which is the function which allocate memory for this linked list node, and that is at the runtime. So here what I'm going to do, I'm going to declare some variable of structure, that is node, This is a node structure, and one more variable, that is a new, means this is what, new node. Okay, for new node I am using the keyword, so not keyword, the variable name is new. Again, it is a pointer type variable. Now here I am writing new is equal to, it is a pointer variable. Okay, the which basically, see, we are going to allocate memory dynamically, and in a C programming we can allocate dynamic memory using malloc keyword. We can allocate memory using malloc keyword, malloc and calloc. Okay, malloc keyword. But there is a syntax to allocate memory in malloc using malloc keyword. So what we need to do, we need to specify the type of memory, means what type of value that uh, what type of memory we are going to allocate. So here we are allocating the memory of node type pointer variable. So that is why I'm here writing node and the pointer variable. So it is a pointer type, node type pointer variable. Okay, then we are going to write the keyword malloc. Okay, then we are going to write the keyword malloc. See, okay, and then how much size of that malloc, dynamically memory. So what type of memory we are going to allocate, that we here we are mentioned, but how much size. Okay, so here I am writing size of keyword, size of what, node, size of node. So here what is the size of node, it is an integer type, integer type, and the next part is a structure to the same node, the pointer to the same node. So again it is a node type. So that is why here I am writing the how much size it will going to allocate, that is a node size, means that structure size. Are you getting me? Okay, so I'm sorry for this. Okay, so here what I'm going to do, I'm allocating dynamic memory using the malloc keyword. But what we need to specify, what type of memory it requires, it is a node type pointer variable, and how much size it requires, that is a node type. Okay, so for this purpose, to understanding the linked list in depth, you must need to know that is a structure in a C programming. In a C programming, structure, then pointer, and then okay, the most important thing is these two, and this the dynamic allocation part, that is malloc. Okay, now here what we did, we allocate dynamic memory for the keyword new, sorry, for the variable new, not keyword, the variable new, and from this function we are returning, we are return this variable to function which call it from to that respective function. So basically get node what it did, it allocate dynamic memory location, it allocate dynamic memory. Okay, now what we are going to see, the basic operation, the first basic operation, insert front, insert at the front of linked list. The front of linked list means what, suppose if you have this linked list having some nodes like 10, 20, 30. Okay, so this is what null means, this node doesn't have next node, null value, and it holds the address of this node. So suppose 301 the address, so this address is stored here. Okay, suppose it has 996 address location, so this address location stored is here, and whatever the address of first node, suppose it has 101 address location, so this address location is stored in a L, since L is our starting pointer node. Okay, so which points to the starting of the linked list, so this is what L. Okay, now suppose you are going to implement the operation insert front. Insert front means what, whatever node comes, new node comes in a linked list, that is attach or add at the front of this linked list. Suppose if you are going to add new node, this is a new node, that is 5, so this node must be in, if you are called insert front operation, so this node must be attach at the front of this linked list. So this will be, so L will going to point to this node, and then 5 will going to point the node 10. Are you getting me? So this is what insert front operation. But sometimes what happens, now initially what we did, this linked list is now empty. There is a no node in a linked list. This, see, we are assigning L is equal to null. This is a starting node, header node of the linked list. So it is initially null. It is initially null. Okay, so we cannot directly attach this value to null. We need to check whether this linked list is empty or not. So now we are going to write the code for, okay, code snippet for insert front operation. Okay, so let's see how it will work. So now I'm going to write the function that is insert front. Okay, this basically takes input as the element and the value, whatever value we are going to insert, that is atom, or you can say element, we are going to insert. And the second parameter it will take, no, it will take only one parameter. See, we are inserting at the front now, so we need only one element. Okay, we need only one element, so integer. So insert front. Okay, now it will take one parameter, the element which we are inserting from user side. Now here I'm going to write the structure variable, that is node. It is a capital variable name, new variable. Okay, then we are going to allocate memory using the function that is get node. See, we are using this get node function to allocate dynamic memory while insertion. So get node, I am calling the get node function, and whatever memory location it dynamically allocate, that assigned to the pointer variable, new pointer variable, which is the type of structure, pointer variable which is a type of structure. So that memory is allocated to whatever dynamic memory is allocated, that is assigned to new variable. Okay, now what we are going to do, so this memory, suppose this memory is allocated. Okay, this memory is allocated for the variable new, which the first part is the data part, second part is a length part. So here what we are going to do, if we want to insert a new element, that is 5, okay, which is collected from the user side. So here element is equal to 5. So this element is passed to this function. We allocate a memory for the new variable, and the next we are going to assign that value new of, see, we are using pointer variable, isn't it? So new of data field. This is what a data field. See, just look at the structure definition. Just look at the structure definition. Just look at the structure definition. Here, integer data. Okay, integer data, and this is a structure type. Okay, so that is why here I am writing new of data. New of data. So the member of structure we are accessing through the pointer variable new. So that is why I am using arrow. I am using here arrow. So new of data. See here. New of, so this is a structure definition. So new of data is equal to this element. So in the data field of, this is what the data field. So in the data field, using this line of code, we are assigning the value 5. So element holds the value 5. So new of data is equal to data, element. New of data is equal to element. And new of link, what will we write here? Link. New of link. So new of link is equal to null. Okay, new of link is equal to null. So this link part holds null value. Are you getting me? And after allocating memory and assigning value to this new variable, this new node, what we are going to do, we are going to check if L is equal to null. Since we just created our linked list and suddenly we call the insert front, we just created our linked list and suddenly we call insert front, so that time our linked list is empty. So we need to check this condition. If L is equal to null, then simply write L is equal to new. Means this L is pointing to this variable new, this new node new. So L is equal to new. So now this one is pointing to this one. So basically this L is become like this. Okay. Else. Now suppose if in your linked list we already have two elements, that is 10 and 5 and 10. So here we doesn't hold, it holds address of next node, and here we have null. So already we have two nodes in our linked list. So that time L is equal to null. No, L holding the address of this node. L holding address of this node. Are you getting me? So L is not empty. So in that case, it will jump to the else part. So in else part, what we are going to do? We are going to write, suppose this is your node. So again you call insert front call. After that it will create one more node, that is new node. So this is new node is created. We are going to allocate memory for this new node. We are going to allocate memory for this new node using get node function. Then after allocating memory, we are going to assign the value for data field. Suppose we are going to insert 25 here in this linked list. Okay, and this is what a null value. Now what here we are going to do in that, after that, if L is equal to null, let's check L is equal to null. No, L holding the address of this node, so it is not null. So it will jump to the else part. In else part, what we are going to do, see what I am going to do, I am going to insert this node at the beginning of this linked list. Means what sequence I want, 25 come first, then 5 and then 10. Are you getting me? So I want to insert this 25 at the beginning of this node. So what I'm going to do, I'm going to assign the address of this node to the link part of the new node. So suppose address of this node is 101 and this node is 991. Okay. So what I'm going to do, so 991 will be stored here already, and we are going to assign the address of this node to the link part of new node. So what I'm going to do here, I'm going to write here new of link. This is the link part and this is what data part. So new of link is equal to, so new के link part को attach करो क्या, new of link is equal to L, the address location which is held by L. So address L holds 101. Basically L pointing to 101. So L points to 101. So new of link. So whatever value which stored in a link part of L, that is stored in a new of link. So here comes 101. So here comes 101. So basically this will going to point the new node, and the next line still your L is pointing to this node 5. Now what I want to do, our starting node must be 25, so L must be point to the 25. So next line is L is equal to new. Just end with semicolon. Every statement must be end with a semicolon. So L is equal to new. So by default this will be vanish and L will going to point the new node, that is 25. So new linked list, updated linked list is like 25, which hold address of 101 means 5. Okay, and this 5 is holding 991 address of next node, that is 10. So this is 10, and this last one holds null value, means there is a no new node. So This is what insert front operation, and from this we are going to simply return. From this we are going to simply return. Okay, end of the else part, end of the insert front operation. Okay, end of the else part, end of the insert front operation. So in this way we can insert at the front of linked list. In this way we can insert at the front of linked list. Now suppose let's check our code one more time whether it is working properly or not. I want to insert the new node which holding the value 35. Okay, so call this function insert front. Here we pass 35. So element holding element is equal to 35. Okay, now here comes which create a new node, okay, so new node, using get node function we allocate a memory for it. So this is a new node created. What I'm going to do, I'm going to use another color marker so it will look good. Okay, that's fine. So what I am going to do, using this new get node function, I am allocate memory for this new node. This is a new node. Okay, and then new of data is equal to what, 35, since we are assigning element. So here comes your 35, and this part is null, the second line. Now check L is equal to null. L is equal to null. L holding nulls? No, it is holding the address of this node, and the address of this node is like 661. So this is what a dynamic allocation. Address of this node is what, 501. What is the address of 501? Okay, 110. Sorry, 101. Okay, 101. The address of this node. And address of this node is what, 991. So this is now scenario. L is holding the address of this node, first node. Okay, so it will not jump to the if part, it will jump to the else part. Now new of link. So this is a new of link which is holding null now. So new of link is equal to L. New of link is equal to L. So now this will going to point in here, and the L is equal to new. So L will not pointing to here, L is pointing to here. L is here. L is pointing to here. So basically your linked list is like this. Finally updated linked list 35, then 25, then 5, and then 10, and this is what your L. So insert front working properly. So that is for today. Thank you very much for watching. Now in next lecture we are going to see insert after. Okay, thank you.